All right, welcome. Today we're jumping right into the engine room of Solana. We're going to talk about its core runtime components and the super important roles that validators play. So, let's get right to it.
Just so you know, this explainer was brought to you by Forge College. Now, if you were with us last time, you remember we followed a transaction from start to finish. Today we're popping the hood open to see the actual machinery that makes that whole trip possible.
So, to get us started, I've got a question for you. What in the world does a high-performance blockchain have in common with a symphony orchestra? Yeah, I know it sounds a little weird, right? But stick with me, because the answer is actually the key to understanding how all of Solana's complex pieces work together in perfect harmony.
So yeah, we're going to run with this symphony idea as our mental model. Trust me, it's a fantastic way to make all these pretty technical concepts feel a lot more intuitive. It helps you see the whole picture before we get bogged down in the nitty-gritty.
Okay, so here's the basic idea. The Solana network, that's our orchestra. The global ledger, that's the sheet music, the score they're all playing from. Every validator node is basically a musician, and they each have their own copy of that score. And for any given time slice, one of those musicians gets to step up and be the conductor, the leader.
Right, so any good orchestra has its different sections. You've got your strings, your brass, your percussion. Well, Solana is the same way. It has its core runtime components, and each one has a very specific job to do. So, let's meet the main players in our symphony.
Here's a quick look at the sections. We've got the messengers, that's the gossip protocol. Then there are the interpreters, which is the BPF execution runtime. After them, the librarians, who are in charge of the accounts database. And finally, the stage managers, which is the snapshotter. Okay, now let's dive into what each of these sections actually does.
First up, we've got the messengers, or what's technically called the gossip layer. I want you to picture this as all the quiet, backstage chatter that happens between musicians. It's not the music itself, right? It's for sharing all those little but super important bits of info, like, hey, who else is on stage? Or who's the conductor for this part? This is how everyone stays in sync and knows who they should be listening to.
Okay, next are the interpreters. This is the BPF execution runtime. BPF stands for Berkeley Packet Filter, by the way. Think of these guys as the real virtuosos. Their one job is to take a transaction, a little piece of the musical score, and play it perfectly, exactly as it's written. And this is so important. The process has to be deterministic. That means if you give two musicians the same piece of music, they have to produce the exact same sound, the exact same state change, no exceptions.
Well, musicians can't play without their sheet music, right? That's where the librarians come in. This is the accounts database. It's literally the library that holds all the sheet music, all the account data on the entire network. It's the one true source of truth that the interpreters read from before they perform, and it's also where they record the outcome of what they just played.
And last but not least, we have the stage managers, also known as the snapshotter. This is a cool one. Imagine a musician shows up late to the concert. Now, are they going to make them listen to the entire symphony from the very beginning? No way. The stage manager just shows them a quick photo of how the stage is set up right now. That's the snapshot. It lets the latecomer get up to speed and join in almost instantly.
Okay, so we've met all the sections of our orchestra. Now let's zoom in and focus on just one musician, a single validator, and see what their performance looks like. Because a validator's job isn't static. It actually moves through 4 different phases.
So this life cycle has 4 main parts. First, they have to join the network. Then, for most of the time, they operate as a follower. Every so often, they get their big moment as the leader. And, sometimes things go wrong and they have to resync or recover. Let's walk through each one.
Phase 1. Joining, or what we call bootstrapping. So our new musician shows up. Like we said, they're not going to replay the entire history of the blockchain. That would take ages. Instead, they go straight to the stage manager, grab the latest snapshot, and bam! They're caught up and ready to play.
All right, so most of the time, a validator is just a follower. In our orchestra, this means the musician is just playing along, listening to the conductor and making sure what the conductor is doing is correct. They're constantly getting these little data packets, which are called shreds in Solana, kind of like little musical passages. And they process them and add them to their own copy of the score.
And then comes the really cool part. Their turn as the leader. Based on a schedule that's already been decided, it's our musician's moment in the spotlight. They get to step up to the podium, grab all the incoming transactions, arrange them into a nice, neat block like a musical phrase, and then they conduct the entire orchestra to play it.
Now you can imagine, with conductors swapping out at lightning speed, keeping everyone on the same page is a massive challenge. So how does Solana do it?
How do they make sure the music never, ever stops, even if a musician falls a bit behind or shows up late?
And this really gets to the heart of why that stage manager, the snapshotter, is so valuable. I mean, sure, you could replay the entire history from block 0, it's possible, but it's painfully slow. Using a snapshot is just wildly, ridiculously faster, and that efficiency is what makes it possible for the network to grow and scale without grinding to a halt.
All right, let's wrap this up. We've met the orchestra, we've seen all the different sections, and we've followed the life of a single musician. Let's go over the big takeaways from all this.
First big idea, a clear separation of concerns. Every piece of the puzzle has one and only one job to do. Second, a validator's life is always changing. They're constantly shifting between following, leading, and sometimes just catching up. And third, snapshots are a game changer. That ability to resync quickly is absolutely crucial for keeping the network both decentralized and scalable.
And that's our tour of Solana's core runtime components. This whole explainer, by the way, was brought to you by Forge College. If you want to go even deeper on this stuff or explore a ton of other Web3 concepts, you should definitely check out their website at forge.college.
But wait, this leaves us with one big question, doesn't it? We've met the whole orchestra, we get what everyone's job is, but what does it actually look like step by step when they play a single note? That's exactly what we're going to break down next time when we look at the transaction flow and processing model. See you then.